Good evening, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic intersymbol interference. So first we can see what is this intersymbol interference. So digital data is represented by electrical pulses. Communication channel is always band limited. When a channel bandwidth is greater than the bandwidth of the pulses, spreading of the pulses will be less. But when the channel bandwidth is close to the signal bandwidth, that is if we transmit the digital data which demands more bandwidth, which exceeds the channel bandwidth, then the spreading of pulses will occur, which causes signal to overlap with each other. This overlapping we call it as an intersymbol interference. So intersymbol interference causes a degradation of a signal if left uncontrolled. Intersymbol interference, in similar to the interference caused by other sources, ISA also causes a degradation of a signals if left uncontrolled. The problem of ISA exists strongly in the telephone channels like coaxial cable and optical fibers. The main objective of to study the effect of ISA when digital data is transmitted through the band limited channel and solution to overcome the degradation of waveform by properly shaping pulses. So, raised cosine response meets a Nyquist ISA criterion. Consecutive raised cosine impulses demonstrate the zero ISA property between the transmitted pulses at the sampling instance. At time t is equal to 0, the mid pulse is at maximum and sum of other pulses is 0. In a communications, Nyquist criteria describes a condition which when satisfied by the communication channel results in no ISI. It provides a method of constructing a band limited functions to overcome the effects of ISI. And this is a diagram which indicates the transmitted waveform and also the pulse dispersion. Pulse dispersion results in the ISI. Intersymbol interference occurs when pulse spread out in such a way that it interferes with the adjacent pulses at the sample instant. So this diagram indicates the intersymbol interference. Here the signals will overlap with each other so that the transmitted signal will be entirely different from that of the received signal. So the amount of ISI can be seen on the oscilloscope using the eye pattern or the eye diagram. Through this eye pattern we can find the amount of ISI can be seen on the oscilloscope using an eye diagram. From the eye diagram, we can determine what is the distortion level, what is the noise margin, and how the signal is being get affected by ISI. So, if in this diagram indicates the actual input waveform and the pulse spreading because of the ISI and the received waveform. So, the transmitted waveform and the received waveform is completely different. This occurs because of the ISI. So, first one is the input waveform and last one is the received waveform. And the mid waveform indicates the signal being affected by the ISI, spreading of pulses. So how to overcome this ISI? How to combat this ISI? There are three strategies allowed for eliminating this ISI. First one is that use of line codes that is absolutely band limited. So this would require sync pulse shape, but can't actually do this, but can approximate that. Second one is that use a line code that is 0 during the adjacent sample instance. So third one is that in second one, if for the pulses to overlap somewhat, we can recover the pulses by making use of the raised cosine roll-off pulse shaping. And third one is that use a filter at the receiver to undo the distortion introduced by the channel. And the filter we call it as an equalizer. So next one is a Nyquist first method for zero ISI. So there will be no ISI and bandwidth requirement will be minimum if a transmit and receive filters are designed so that overall transfer function is given by h of I is equal to 1 by f pi of f by f naught. So this type of pulses will allow the signaling at the baud rate of d is equal to 1 by ts is equal to 2b. And next is a Nyquist first method for zero ISI. Since pulses are not possible to create due to infinite time duration, sharp transition band in the frequency domain. Sync pulse can cause a significant ISI in the presence of a timing error. And next is a filter which can be used at the receiver to undo this ISI. We call it as a Nyquist filter or a raised cosine filter. So the impulse response transfer function of this Nyquist filter is given by pi into f by 2f naught plus y of f. So that's all about the ISI. We have seen what is ISI and how it affects a signal. What is, if a signal is affected by ISI, how the transmitter and receiver pulse will get vary, and also we have seen various strategy to combat this ISI. Thank you.